Planet Earth, a world dominated by water. Oceans cover over 70% of its surface, plunging to depths that remain largely unexplored. The deep sea, a realm of perpetual darkness and crushing pressure, holds mysteries that have captivated humanity for centuries. In this alien environment, life takes on strange and wonderful forms. Creatures of the deep have adapted to survive in conditions that would be instantly lethal to us. They navigate a world without sunlight, where food is scarce and danger lurks in every shadow. Our journey begins in the twilight zone, where sunlight fades into an inky blackness. Here we encounter creatures like the anglerfish with its bioluminescent lure, and the giant squid, a legendary monster of the deep. As we descend further, the pressure increases and the temperature plummets. Yet even in this extreme environment, life finds a way. Join us as we explore the secret world of the deep sea, a realm of wonder and discovery.
The deep sea is not a single environment, but a series of layers, each with its own unique characteristics. The first 200 meters, known as the epipelagic zone, is the realm of sunlight and familiar marine life like dolphins and whales. Below this lies the twilight zone, extending to 1,000 meters. Here, sunlight fades to darkness, and the water pressure increases dramatically. Creatures in this zone are often bioluminescent, using light to attract prey or communicate in the darkness. Below 1,000 meters lies the abyssal zone, a vast dark expanse covering much of the ocean floor. The pressure here is immense, reaching hundreds of times that at the surface. Temperatures hover near freezing. Yet, even in this extreme environment, life persists. The deepest part of the ocean is the Hadal zone, found in trenches that plunge to depths of over 6,000 meters. These trenches are home to some of the most extreme life forms on Earth, adapted to survive in conditions of crushing pressure, perpetual darkness, and scarce food.
Life in the deep sea has evolved unique adaptations to survive in this challenging environment. Many creatures, like the anglerfish, have bioluminescent organs that produce light through chemical reactions. This light can be used to attract prey, startle predators, or communicate with other members of the species. Other adaptations relate to the scarcity of food. Many deep-sea creatures have evolved slow metabolisms, allowing them to survive for long periods without eating. Some, like the gulper eel, have enormous mouths and expandable stomachs, allowing them to swallow prey larger than themselves. The lack of sunlight also means that deep-sea creatures cannot rely on photosynthesis for energy. Instead, they depend on chemosynthesis, a process where bacteria convert chemicals from hydrothermal vents into energy. These vents, found on the ocean floor, release superheated water rich in minerals, supporting unique ecosystems. The deep sea is a testament to the adaptability of life, showcasing the remarkable ways organisms can thrive in even the most extreme environments.
In the absence of sunlight, bioluminescence plays a crucial role in deep-sea communication. Many creatures use flashes of light to attract mates, confuse predators, or lure prey. The patterns and colors of these flashes can be species-specific, allowing individuals to recognize each other in the darkness. Some species, like the vampire squid, release clouds of bioluminescent fluid to disorient predators. Others, like the hatchetfish, have photophores that can be angled to control the direction of their light. These adaptations highlight the importance of light in a world where sight is limited. The deep sea is not a silent world, but one filled with flashes, glows, and shimmering displays. These bioluminescent signals provide a window into the complex communication networks that exist in this hidden realm. The study of bioluminescence in the deep sea is still in its early stages, but it offers fascinating insights into the evolution of communication and the remarkable adaptations of life in extreme environments.
Section 5. A world of extremes. The challenges of pressure and temperature. The deep sea presents immense challenges for exploration, with pressure and temperature being the most significant. For every 10 meters of depth, the pressure increases by 1 atmosphere. At the deepest point in the ocean, the pressure is over 1,000 times that at the surface. This extreme pressure makes it difficult to build submersibles that can withstand the crushing weight of the water. Special materials and designs are required to ensure that these vehicles can operate safely at such depths. Temperature also poses a challenge. While surface waters can be warm, the deep sea is consistently cold, hovering near freezing. This extreme cold can affect the performance of equipment and make it difficult for humans to survive outside of pressurized submersibles. Despite these challenges, scientists and engineers have developed innovative technologies to explore the deep sea, revealing its secrets and expanding our understanding of this extreme environment.
Section 6. Windows to the deep. Submersibles and remotely operated vehicles. Exploring the deep sea requires specialized equipment capable of withstanding extreme pressure and providing a safe environment for humans or instruments. Submersibles, manned underwater vehicles, have played a crucial role in deep-sea exploration. These vessels, equipped with thick hulls and advanced life support systems, allow scientists to descend to great depths and observe the deep-sea environment firsthand. Remotely operated vehicles, or ROVs, are another essential tool for deep-sea exploration. Controlled from a surface vessel, ROVs are equipped with cameras, lights, and robotic arms, allowing scientists to explore the deep sea without the risks associated with manned submersibles. These vehicles can collect samples, conduct experiments, and capture high-definition images and videos of the deep-sea environment. Submersibles and ROVs have revolutionized our understanding of the deep sea, providing invaluable insights into this once inaccessible realm.
Section 7. The ocean floor, a tapestry of volcanoes and vents. The ocean floor is not a flat, featureless plain, but a dynamic landscape shaped by volcanic activity, tectonic plate movement, and the constant deposition of sediments. Mid-ocean ridges, underwater mountain ranges mark the boundaries between tectonic plates. Here, magma rises from the Earth's mantle, creating new crust and pushing the plates apart. Hydrothermal vents, found along mid-ocean ridges and other volcanically active areas, release superheated water rich in minerals. These vents support unique ecosystems, with bacteria forming the base of the food chain. Abyssal plains, vast flat areas covering much of the ocean floor, are covered in fine sediments that have settled over millions of years. These plains are home to a variety of creatures, including sea cucumbers, brittle stars, and deep-sea fish. The ocean floor is a testament to the dynamic forces that shape our planet, a landscape constantly evolving and teeming with life adapted to its unique conditions.
Section 8. Life in the abyssal plains. Unexpected oases. While the abyssal plains may seem desolate at first glance, they are home to a surprising diversity of life. Creatures here have adapted to survive on the scarce food that falls from the surface, often relying on scavenging or predation. Sea cucumbers, worm-like creatures that crawl along the ocean floor, ingest sediment and extract nutrients from it. Brittle stars, with their long, delicate arms, scavenge for food particles. Deep-sea fish, often bioluminescent, have evolved unique adaptations for hunting in the darkness. Hydrothermal vents, found scattered across the abyssal plains, provide oases of life in this otherwise food-scarce environment. The discovery of life in these extreme environments has challenged our understanding of the limits of life on Earth and raised intriguing possibilities for life on other planets.
Section 9. The deep sea, a source of wonder and resources. The deep sea, long shrouded in mystery, is now recognized as a source of wonder and potential resources. Its unique biodiversity holds promise for new medicines, enzymes, and other valuable compounds. Mineral deposits on the ocean floor, including manganese nodules and cobalt-rich crusts, are attracting increasing interest as potential sources of raw materials. However, the potential for resource extraction from the deep sea must be balanced against the need to protect this fragile and poorly understood environment. Deep-sea mining could have significant impacts on ecosystems and species that are only beginning to be understood. The challenge for the future is to balance the need for resources with the imperative to protect the deep sea and its unique biodiversity for generations to come.
Section 10. Conclusion: our responsibility to the deep. The deep sea, once considered a barren and lifeless wasteland, is now recognized as a vital part of our planet's ecosystem. It regulates climate, provides food, and holds a wealth of biodiversity that is only beginning to be understood. As we continue to explore this final frontier, we must do so responsibly, recognizing the importance of protecting this unique and fragile environment. The deep sea is not ours to exploit, but a global commons that requires careful stewardship. By understanding and appreciating the wonders of the deep, we can ensure its preservation for generations to come.